The purpose of today's lesson is really to just give you some more practice on those dimensional analysis ideas that we started talking about yesterday. So we're going to be looking at some of the examples together from this worksheet, which you have access to. You also have the examples in your student learning map packet and the examples from your textbook. Now, some of these examples I actually went over in the video that I recorded for yesterday. So for those examples, I'll just tell you to skip ahead or go back and view the video if you're stuck. But really the purpose of this video is for you to use the individual examples after you have attempted to do the example by yourself, just so that you can make sure that your thought process was correct and to check your answers. It's also a good place that if you're just completely stuck, to go through and actually listen to where I have modeled my thought processes so that maybe you can start to think in terms of how to solve these dimensional analysis problems just a little easier. So the first problem here says convert 12 miles to kilometers, and it even tells you that there are 5,280 feet in 1 mile, which is important because that's not anything that I've given you information about over in our normal chart, since miles are really bigger than what examples we usually look at in the lab. Usually we're measuring distances on a ruler. Obviously, our first example then is going to have us convert miles to kilometers by first looking at miles and feet, because that's the one that was given to us. So if we go from miles to feet, now we're in a unit that is included in our chart. So what I would do is start by planning this out a little bit. Make sure that you can get from point A to point B using the equalities that are given. So miles to feet, and then over here, feet can go to inches. And that's important because we know the exact equality change between inches and centimeters, which now lets us get into our metric system. Centimeters can then go to our base unit of meters, and then meters can go back to the prefix of kilometers. Again, I'm hoping at this point that you've tried the problem and you're ready to look at the answer. So when I'm looking at my equality here, I started with miles, canceled miles to go to feet, canceled feet to go to inches, inches into centimeters, centimeters into meters, and then meters into kilometers, which gave me an answer of 19.312128 kilometers. Thinking in terms of significant figures, which again, you're not officially responsible for quite yet. We haven't done that lesson. But if you think back to what Mr. Simon taught you, we were only given two significant figures here, which means our final answer should actually be recorded to two significant figures, 19 kilometers. Our next example is actually looking at days to seconds. Those equalities aren't given to you because they are so incredibly common, and it is knowledge you should have, but we will set it up looking at the process of dimensional analysis. So you know that days go to hours, hours go to minutes, minutes goes to seconds. Once you've tried it, you can compare it to the work here. Days, hours, hours, minutes, minutes, seconds, and we wind up with 2,592,000 seconds. We were given one significant figure, so really it should be recorded to one significant figure. The 2.5 rounds up to a 3, and then we can use our scientific notation to write it correctly. Our third example, 14 meters to inches. We start with our known equality of 14 meters. That's our measurement, the measurement of 14 meters. And then we can turn meters into any of these with the prefix. Now, because we know we want to go to inches, we said last time we looked at this example, centimeters is really the metric unit we should be aiming for. So we go meters to centimeters, centimeters to inches, and we get our final answer of 551.18 inch, which we could round to the appropriate significant figures and write that as either 550, trailing zeros are not significant without a decimal, so we could leave it like that, or we could write it as 5.5 times 10 to the 2 inches. 175.8 milligrams to grams. Milligrams can go back to the base unit grams just using one simple conversion, which looks like this. And since we had 4 significant figures, we really should keep all 4 significant figures, which means that is also our final answer. The next example we actually already did together, so I'm going to skip that one for now. The only thing that I will point out to you is that when I wrote it, I could write it as 125,000 or 1.25 e to the 5th. Either way, it's 3 significant figures. And the next example, I believe we also already did that one, so I'll go ahead and skip that one for now. Let's go back down to this megasecond one. If we're going from megaseconds to milliseconds, we're sticking with our metric conversions, but because both of them had prefixes here, we'll actually need 2 steps to the conversion. Megaseconds will go to seconds, and then seconds will go to millisecond. If you notice how I wrote it out, both places, the unit that had the prefix, mega and milli, both of those get the 1 from the chart, and both places where we had just the base unit without a prefix, the seconds, those got the exponential factors from the chart. Final answer written to 2 significant figures using scientific notation. So I can write that as 4.5 times 10 to the 10th. I could write it as 4.5 e10. Or if you really wanted to, you could write out a bunch of zeros afterwards and actually have 4.5 times 10 to the 10th with the 9 zeros written out. The next example I'm just including to point out to you that liters and centimeters cubed are both units of volume. I know it looks like a distance, but because this distance is cubed, that would be like length times width times height. That is a volume measurement. And there is one often overlooked equality here, where I've told you that a centimeter cubed is exactly the same thing as a milliliter, that without that equality, you might get stuck on this one. But really all you have to do is change liters to milliliters, because then milliliters can go to centimeters cubed, and it's a fairly simple conversion at that point. And then finally, the last one we had done yesterday, but I'm leaving it in as a reminder here because this is much like the one that's also in the notes sheet where you had a squared unit. If you're using squared units that weren't squared in the chart, it's not as simple as just rewriting the equality from the chart. If you square the unit, millimeters and meters squared, you also have to square the equality from the chart. So even though milli was 10 to the negative third, you see I wrote it as 10 to the negative 6 because I squared the negative 3. So negative 3 times 2, negative 6, which got me my final answer there. So again, the purpose of this video is to allow you to check your answers from this unit conversion practice worksheet, and just so that you can see how I got from these equalities, which you'll be given on your quizzes and tests, to actually using the dimensional analysis. Continue to do the examples in your student learning map. Continue to do the examples in your actual textbook. If you want more examples, feel free to email me. I can show you some more examples for you to try, but you really want to try to get dimensional analysis down, and you want to really focus on all 3 types. So we've got some that are English to metric, we've got some that stay in metric, and then we also have the ones that include either squared or cubed units. Once you feel proficient in all 3 of those and you've done all the required examples, we can absolutely move on to talk a little bit more about things like significant figures. But it's super important that you understand dimensional analysis before we go any further.